January 2025. Your Wi-Fi drops twice a week, maybe. Annoying, but whatever. January 2026. It drops 8 times a day and your video calls freeze mid-sentence. Your bank app crashes when you try to transfer money. Your car's backup camera flickers, then goes dark. January 2027. None of those things work anymore. Not because the devices broke, they didn't. Because light itself got slower, and everything that depends on light moving at its current speed just stopped working. That's what would happen if the speed of light dropped by 1% every year. Please like and subscribe while I continue my yapping. Here's what nobody tells you about fundamental constants. We didn't choose them. We discovered them. And then we built literally everything around them. Every GPS satellite, every fiber optic cable, every MRI machine, every nuclear reactor, they all assume light moves at a specific speed. Not pretty fast, not close enough, exactly that speed. If light slowed down, those assumptions wouldn't just be wrong, they'd be catastrophically, unpredictably wrong. Start small, your phone. The timing chip inside it, smaller than your fingernail, sends billions of signals per second. Those signals move at light speed through microscopic circuits. The chip knows this. It's designed for it. But say light slows by 1%, suddenly signals that should arrive in 0.1 nanoseconds arrive in 0.101 nanoseconds. Your phone's processor would try to read data that isn't there yet. It would write over data it should be reading. Within weeks, your phone wouldn't freeze. It would hallucinate. The apps would open that you didn't click. Messages would send to the wrong people. Photos would corrupt as they saved. A repair tech in Bangalore wouldn't know what to do. She'd see the same problem on 50 phones in a month, but every diagnostic would come back clean. The hardware would be perfect. The software would be updated, and yet the phones would keep glitching in ways that made no sense. Scale up. GPS satellites. There are 31 of them, and they all have atomic clocks that tick with such precision they'd only drift by 1 second every 300 million years. Except those clocks depend on light speed to stay synchronized. They beam signals to Earth, and your phone calculates where you are by comparing how long each signal took to arrive. But if light slows, those signals would take longer. Not much longer. Just a tiny fraction of a nanosecond longer. That's enough. Your GPS would say you're 50 meters west of where you actually are, then 100 meters, then half a kilometer. By year 2, Uber drivers would stop trusting their apps. Delivery trucks would miss their routes. Ships navigating narrow channels would run aground because their instruments said they had room. Now the real problem starts. Nobody would know light slowed down, because how do you measure the speed of light? You send light from point A to point B and time how long it takes. But you measure time with clocks that use light. You measure distance with lasers that use light. If light slows down, all your measuring tools slow down with it. You'd be using a broken ruler to measure a broken ruler. Dr. Reyes, who runs the Atomic Clock Lab in Boulder, Colorado, he would notice her clocks drifting. Not all at once, just a few microseconds here and there. She'd recalibrate them. They'd drift again. She'd assume it was equipment failure. She'd replace the cesium atoms, the vacuum chambers, the magnetic shielding. Nothing would help, because the problem wouldn't be the clocks. It would be time itself, or at least what we use to define time. The frequency of light emitted by cesium atoms. If light slows, that frequency changes. The second you measured last year wouldn't match the second you measure this year. 3 years in, the scientific community would split into factions. Some physicists would insist the measurements were wrong. Some would say the equipment was faulty. A few would whisper that maybe, just maybe, a fundamental constant was changing. They'd be shouted down, laughed at. Because constants don't change. That's what makes them constants. But chemistry wouldn't care about the argument. Electrons orbit atoms at speeds determined by light speed. Slow light down, and electrons would orbit differently. Not wildly differently, just enough that the bonds between atoms would weaken. Medications that used to work would metabolize too slowly. Plastics that used to be flexible would become brittle. Steel beams that were stress-tested for 50-year lifespans would develop microfractures in 30. A structural engineer in Jakarta would pull a sample from a 5-year-old bridge and find the metal fatigued like it was 15 years old. She'd blame the manufacturer. The manufacturer would blame the specs. The specs would be fine. The bridge would still be failing. By year 4, With the panic wouldn't be about phones or GPS anymore. It would be about nuclear reactors. Reactors are designed down to the atom. Engineers calculate exactly how much uranium to pack into fuel rods, exactly how much water to circulate, exactly how much heat the core will produce. Those calculations use Einstein's equation. E equals mc squared. Energy equals mass times the speed of light squared. If light slows by 4%, the energy released by splitting atoms would change. Not by 4%, by 8%, because you're squaring the speed. A reactor in France built to produce exactly 900 megawatts would suddenly produce 828 megawatts. The cooling systems would be over-engineered for the heat being generated. The reactor would run cold. Engineers would compensate by adding more fuel. Then light would slow another percent. Now the reactor would overshoot. The cooling systems, barely adequate before, would strain. Temperature sensors would read normal because they'd be calibrated to the old light speed. By the time anyone realized the reactor was running hot, it might be too late. The night shift supervisor wouldn't see it coming. He'd see pressure rising, but not fast enough to trigger alarms. He'd see coolant flow decreasing, but within normal variance. Then in the span of 4 minutes, the core would spike. Not Chernobyl level, not immediately, just enough to force an emergency shutdown. Just enough to make people wonder if they could trust any reactor anymore. And meanwhile, the sky would be lying to you. Astronomers would point their telescopes at distant galaxies and see light that left those galaxies billions of years ago. But that light would be traveling slower now than when it was emitted. Stars that appeared to be 13 billion light years away would look farther. Galaxies that were moving away from us at a certain speed would seem to be accelerating faster than before. Cosmologists would think the universe's expansion was speeding up, when really light was slowing down. Every observation would be suspect. Every theory built on those observations would crumble. The timeline of the universe, the age of stars, the distance to the edge of the observable cosmos, all wrong. Not because we measured badly, but because the thing we were using to measure changed mid-measurement. Year 5, the inequality would become unbearable. Because here's the thing about cascading infrastructure failure. It hits the wealthy last and the poor first. One Silicon Valley would notice their servers lagging. Lagos would notice their entire electrical grid failing. A hedge fund in London would lose milliseconds on stock trades. A clinic in rural India would lose its only X-ray machine. Advanced economies would have the resources to recalibrate, to rebuild, to engineer solutions, even if they didn't understand the problem. Developing nations wouldn't. They'd just watch their technology stop working and have no way to fix it. Food supply chains would fracture. Modern agriculture runs on GPS-guided tractors, climate-controlled greenhouses, and precisely timed irrigation. Lose those and yields drop. Not everywhere. Farms in Iowa might adapt. Farms in sub-Saharan Africa wouldn't have the margin for error. Famine wouldn't announce itself. It would creep in, one failed harvest at a time. And through it all, the argument would rage. Is this real? Because if the speed of light can change, what else can? The gravitational constant? The charge of an electron? The laws of thermodynamics? Scientists would have spent their entire careers assuming the universe runs on fixed rules. That assumption would be dying, and with it, the certainty that we can ever truly understand anything. Some would double down, insisting the measurements must be flawed. Others would spiral, questioning whether any scientific knowledge was reliable. By year 6, it wouldn't matter who was right. The systems would be failing faster than we could patch them. And even if someone figured out that light was slowing, even if they proved it beyond doubt, what then? You can't fix the speed of light. You can't file a maintenance request with the universe. You could only watch as every equation, every formula, every physical law you thought was permanent turned out to be temporary. Just rules written in sand, waiting for the tide.